All right, I'm going to explain the chi-square test. I'm going to keep this really, really simple. All right, so in this example, we'll look at some data on girls and boys and preference playing soccer and hockey. And we're going to look to see if whether or not the difference between girls and boys is just due to randomness. In other words, there really is no difference between girls and boys, or if there is some sort of gender bias going on. So we're going to do something called the chi-square test. And the chi-square test is going to spit out a result. And the result is either going to tell us whether or not there is some sort of significance in the data, or really there isn't. Now, we're going to use what's called a p-value of 0.05, and the chi value associated with that is 3.84. Now, if the value we get is less than 3.84 at the end of this, that means the null hypothesis is accepted. So there is no difference in the preference between girls and boys. That any difference that we do see is just randomness. But if the value is greater than 3.84, then the difference that we see is most likely, and here's that p-value comes in, so this is 5%, so it's 95% most likely due to gender bias. So let's take a look. So first thing we do is we set up a little table. So we have girls and boys. So we can see it's basically it's a 2x2 grid because we have girls or boys, and we have soccer or hockey. So we have 4 possible outcomes: girls soccer, girls hockey, boys soccer, boys hockey. This is the data we collected. Okay? So maybe you did a survey, you found out 100 girls play soccer, 80 boys play soccer, 60 girls play hockey, 110 boys play hockey. So this is the column for your totals for soccer. So we have 180 people playing soccer. This is the total for hockey. We have 170 playing hockey. The total of all the individuals is this one, the bottom right corner. So we have 350 kids playing in total. This total is for this column, which is just the total number of girls, so 100 plus 60. This total is for the total number of boys, which is 180, because it's 80 plus 110. Now, the expected is what you would expect to see if there was a normal random distribution of boys and girls playing soccer. The way you figure out this expected value is quite simple. This is cell 1, so it would be the total from cell 1, the total from row 1, which is 180, times the total from column 1, which is 160, over the total, 350. Now that would give us the value of 82.3. So if everything was random, we would expect to see 82.3 girls playing soccer. Now we can say 0.3 because this is a calculated value. Here, the expected for boys playing soccer, again, this is in row 1, so it's the total from row 1. This is in column 2, times the total from column 2, over the total, 350. So that would give us a value of 97.7. For this one, this is column 1, so it's column 1 total, times row 2 total, over the total, and that gives us an expected of 77.7. And then for boys and hockey, we would expect, let's figure this out, 170, this is in row 2, times total from row 1, 190 over 350. That gives us a value of 92.3. So we would expect 92.3 boys to be playing hockey. Now, is the difference between observed and expected random? Nothing's really going on? Or is there some sort of bias going on? Let's do the chi-square test. So, let's look at girls and soccer. Girls and soccer. So girls, 100 observed playing soccer. We expected 82.3. This is the chi-squared formula. It's the sum of observed minus expected squared over expected. So for girls soccer, the observed was, as we saw, 100. So it's 100. The expected was 82.3. So it's going to be that squared over the expected. If we do this calculation, we get a value of 3.8. Now, we can do that for all four scenarios. So girls in hockey. So for girls in hockey, the observed was 60. You see it right here. The expected was 77.7. So if we do the chi-squared calculation for just this part, it would be 60 minus 77.7 squared over 77.7. That gives us a value of 4. Here's the one for boys soccer, 3.2, and boys hockey, 3.4. Again, it's just observed minus expected. You can see that squared divided by the expected. When we're done, we add up all of these values. So remember, the chi-squared value is this sum. So it's going to give us a sum total of 3.8 plus 4.0 plus 3.2 plus 3.4. This is 7.8 plus 3.2 is 11 plus 3.4 is 14.4. So our chi value is 14.4, and it's greater than 3.84. Therefore, we can reject a null hypothesis and say with 95% certainty, in other words, there's a 5% chance we could be wrong, but we can, pretty confidently say that there is a gender bias because that value is greater than 3.84. All right, that's a very simple explanation of the chi-squared test.